Alright, so everyone, these are what we call a panel. Okay, and there's 6 panels, and you'll notice this is the only panel without water. Okay, the first thing I want everyone to do is hit their question mark. And this tells you this is what generates electricity, this is what transmits it or moves it, and these are the people that use it, our consumers. You'll also notice on the legend or this table that it's nighttime and the sun is out, and right now the wind is high. So it's good for wind energy. Although it's night, it's not good for solar unless you had what's a backup generator or battery. Okay? So what you do is you're going to need one pretty much from each area to get electricity. So we'll start off by taking the neighborhood. We'll put it here, wherever you want to live. We'll take the solar energy, put it here. And now again, it's nighttime. So if I go like this, connect the two, the word explain is an explanation. And if I read the explanation, it says at night you need a battery to provide solar power. So that's where this comes in. And you want to charge your photovoltaic panels, photo meaning light, but without the sun. Now the sun is out. And now it's got another problem. The voltage is too high. So if I remember, the step-down transformer is the yellow one. So in order to step it down, you have to use this step-down transformer. Put it right on the red line, and voila, you have it. Now, if I hit that, it says off the grid, because you're using solar power. Now again, you notice that it's daytime, so the sun is out. So if I went like this and took it off, you don't really need the battery at this point. It's going to need it. We'll watch what happens when the day turns to night and the moon comes out. You know you're going to need this. So right now, although you don't need it because the sun is out, watch what way the green line is going. The green line is going from the cells in the photovoltaic panel. Oh, now it just switched. So you witness alternating current. So now, if I went like that, you'd have a problem. So you definitely need this battery. And we refer to Nikola Tesla up there, and he's the one who created this, or it's his invention, alternating current. Direct current just goes the one way, alternating exactly what it says. It alternates direction. Okay, so right there we demonstrated off the grid because it's solar energy. It's not the hydro plant. So now we'll do the next demonstration. We'll swap out this solar and we'll replace it with wind energy. So right now the wind is high, so it works. Again, the wind just went to low. So you notice you had 2 problems to troubleshoot. This one says not enough power, and this one says no wind power. So we have, again, the battery has to charge it, and the green line is going that way. Without it, it would not work. With it, the battery's charging the wind tunnel, or the wind farm. And if I hit this, again, it's going to say off the grid. Right now, what we're going to do is we're going to move to a panel that has water, and we're going to use the hydro plant. If at any time you forget what they are, on each side, either side, we do have the table, or just hit your question mark again, and it'll highlight for you. So right now, we have water in this. If I were to put it anywhere but the water, it's going to give me an arrow. It's going to tell me that. It'll explain the hydro generator needs flowing water to generate power, so move it to the nearest river. Okay? If I put it over here, it's not going to work. It has to be flowing water in the river. And of course this has to come up blue. There it is. So if I take the neighborhood and I want to power it, go like that, and we have a fire because there's too high a voltage. And it tells you right here, voltage is too high, it can cause a fire or another problem, you'll need to have a step-down transformer. Again, this is a step-down transformer, you put it there, connect it, if it comes apart, and voila. Unlike off the grid like this, it just tells you you're successful, because you're using clean, reliable energy, the hydro plant. If I was to have say an industry, okay, and now I'm going to swap it out for an industry. Now you have all sorts of problems. Right here it says voltage too low. Another one that says voltage too low. And this one says not enough power. So what this is telling me, we saw before it worked on the residential area, but now it's not working for a hydrant plant. So what we have to do is we have to hit this, and it gives us an option. You either dial over to 11,000 volts, and it took care of the two issues, or you can touch it. And that takes 11,000. The industry takes more than the residential. But we still have one more problem. We have not enough power. So we're going to talk about STEM, science, technology, engineering, and math. The math component is what we're going to talk about. Some schools call it STEAM now, for the A for arts, or STREAM for religion and reading. So we'll talk about the math component. We know that it says there's not enough power. So we also have a drop-down box here, and we need to turn another generator on. So try 2. It works. So this tells me for industry, unlike the neighborhood, it takes 2 for every 1 industry. So it's a 2-to-1 ratio. So if I were to add another one, and we connect them, boys and girls, 2 times 2 is 4, so we have an option, 4. If I thought it was 3, it wouldn't be enough. Okay, so that's 4. Again, you could dial it as well.
Nice.
So if I take 2 more, and I want to have, say, we're in Hamilton, Ontario, in the industrial park, right? We have a whole area of industry. So 2 times 4 is 8, and this only goes up to 4, so you're going to have to add another one. Connect the 2, and again, hit it down. 4 plus 4 is 8, and there you have it.
Could you also replace your step-down transformer with a step-up transformer?
You could if you use your 345 kV line, and that would be this one. This will tell you, if you put it down, it's a high transmission line. It says power line tower. I for information. It says this is a transmission tower. It supports wires carrying high voltages of electricity, typically 345,000 or more volts, and it goes 10 miles. Okay? And what else can I say? I can take this and go a longer distance. We can maybe even, I see kids take it from one area all the way to the other. It's a little stretch, but it'll work.
Okay.
Okay? So now we have industry we've done, neighborhood we've done solar energy, we've done, what else? We've done the wind farms.
And the wind.
Okay, so the only one we haven't used is the red one and this here one right here. So, if I were to go, what's it telling me? No wind power. Whoa! The wind changed. It was low. It just went high. But now it's a fire because you're only going into a neighborhood. And anything more than a 220 line will give you a fire. So this is way more. This is 345,000 volts. So we have to step it down. And that's what you asked for. You asked if you can go step up and step down. So you went from a high transmission line, like this one right here, that blue line. That's our 345,000 volt line going into the utility pole. And without that bucket on it, which is the yellow one, the step down transformer, we'd have a fire.
Yep.
So now we have something else going on. The wind. So you know you're going to need a battery. There you are. Okay? And again, you'll notice which way the line is going. The battery is charging this. And when in this case, it's wind. When the wind goes high, this will alternate the direction.
Sweet.
So you've used every one of them. I could try to go a farther distance.
Look at that.
could try to go over here.
Now you're running low.
Switched. It's probably the wind. Yeah. Well, it's nighttime. The wind is high, but let's see. All you have to do is troubleshoot it. Not enough power, okay? Because we stepped it down.
So if you took the step down out of the mix right now, do you think you'd have enough, or it'd be too much?
No, you still have a fire. You can't go anything higher than the 220 line into it. But what we could do is we could add an alternate. We can add some more wind. We could, well, actually, we could add it to the battery. See if this helps. There we go.
There you go.
Yeah.
Now, could you also tie into this industry over here? Is that possible?
In that case, you would need this step-up transformer because you're getting see this? That's at
yep.
Too much. So
maybe you put in a high voltage line.
We'll do that. Well, actually, you don't need to tie into that because it's already on its own.
Yeah. Neat.
Yeah.
All right, I think we got it all.
Okay.
Great job. I'm going to shoot that. So those are step-down transformers on every pole when you see